Hey class, this is Gigi. I am giving you some help here in the movie screen problem in my math lab homework. This question said that you are just basically standing away from the movie screen and looking up, right? The distance is 6 and 20 as in the picture here, This is 6 from the bottom, from the ground up, and that is 20 from the ground to the top. Okay, now when looking at this picture, we see that there are two right triangles. Okay, so there are two right triangles, the big one, where this is 20, this is X, and I'm going to call that angle B. Okay, so that angle right there is, I'm going to call that angle B for big angle. And then we have a smaller right triangle here, where this is also X, but this right here is 6, and I'm going to call that angle A. Okay, so now when you're looking at, I'm going to call that A. So then when we are looking at this picture, the angle that we are dealing with is theta, right? So we can see that angle theta is going to be angle B minus angle A. Okay, so we need to actually be focusing on the angle A and angle B. And the reason why we would want to relate A and B to theta is because when we use trigonometry, we use trigonometry in right triangles. And angle theta there is within a non-right triangle. Okay, so all right, what else is the question giving us here? So the question is asking, what is the rate of change of your viewing angle? That would be d theta dt as you are walking away from the screen. D theta dt is what? When you are already at 20 feet away from the wall, and the rate of which you are walking, which would be dx dt, because you're walking right here, right? So the rate of that would be your dx dt. So, and dx dt is 2 feet per second. Okay, so those are the information that's given to you. These are the given information. This is what the question is asking. And we are having to relate theta to angle A and angle B. Okay, now, as we can see here, angle B, tangent of B, because we have opposite over adjacent, so we're talking about tangent. B is equal, tangent of B is 20 over X. Therefore, B is the inverse tangent, okay, of 20 over X minus angle A. Angle A in this case is, so tangent of A is 6 over X. So A would be inverse tangent of 6 over X. And then that is your theta. Okay, so what are we going to do to that equation? That's the equation that we're working with, right? This right here is the equation that we are working with. And the question is, what are we doing with that? Okay, so I'm not sure why I wrote it all the way over there, but I'm going to go ahead and move this over so I have room. And also for you to think about that just a second here. So angle theta is angle B minus angle A. Angle B is inverse tangent of 20 over X, and angle A is inverse tangent of 6 over X. All right, so now we are going to take the derivative of both sides with respect to t. Okay, so then on the left-hand side, we will have d theta dt. On the right-hand side, the derivative of inverse tangent is 1 over 1 plus something square, and that thing right there is the input, 20 over x square, and 20 square, I'm going to go ahead and write 400 over x squared, multiply by the inside derivative, which is the derivative of 20 over x. 20 over x can be thought of 20x to the negative 1. So when we take the derivative of that, with respect to t, then it would be 20x to the negative 2 multiplied by dx dt. Okay, so this can be written as 20 over x squared and then dx dt. Okay, same concept. We're going to do that exactly one more time here. Minus, okay, then the derivative of inverse tangent is 1 over 1 plus the input square, and the input here being 6 over x, so that would be 36 over x squared, multiplied by the inside derivative, and the inside derivative would be negative 6 over x squared dx dt. Okay, and we have a negative here actually, negative 20. Okay, so let's clean that up. d theta dt is going to equal to, now when you multiply the x squared, take the x squared and distribute into each one of these, that's going to cancel out this x squared. So on the numerator, you will have negative 20. On the denominator, you will have x squared plus 400 dx dt. And then minus, similarly, you will say, when we distribute this x squared into here and here, this is going to be gone. So I have x squared plus 36, and then I have negative, negative makes it a positive 6 on the numerator, multiplied by dx dt. Now we're going to pause there and say, okay, what information was given to me, and what can I do about that? Okay, so we are going to go ahead and replace the dx dt with 2, and then x is 20, so that would be negative 20 over 20 squared plus 400 multiplied by 2 plus 6 over 20 squared plus 36 multiplied by 2. And when you punch that information into your calculator, you can say that d theta dt is approximately negative 0.022477, and this is the measure of length, and we're talking about arc length. So the unit here would be radian per second. Now, when you are talking radian per second, it's kind of hard to visualize the angle being radian per second. So if you would like, you can go ahead and convert that into degrees. And when you convert that into degrees, it is approximately 1.29 degrees per second. Okay, now maybe degrees will be easier to think in real life, up to you. But the answer, I think, in my math lab, it is looking for radian per second, because we are talking about these length, right? The unit of measure of angles as relate to arc length is called radian. So we say radian per second.